Okay, Algebra 2, day 4 notes is all about the unit circle. The unit circle, the radius is 1, the center is the origin. Before I do the unit circle, a little review from the first couple days. You were making rotation diagrams, stuff like that. Remember 0 degrees is always over here to the right, positive x-axis. Some things you already should know, you probably do already. Alright, some angles. 90 degrees, 180, 270. Alright, obviously 360 is back to where you started. If you see angles that are bigger than 360, just keep going around the circle. Alright, so 90s could also be 450. Alright, 180, that can also be 540. If I go around the circle more than once, keep going. You could also go in the negative direction. So if this is 0, 270 is the same as negative 90 degrees. Right, 180 is the same as negative 180. Negative 270 is the same as positive 90. Things like that, keep track of. Today, the unit circle. The notes are kind of wordy, so I'm just going to do some stuff on the side, essentially. You can read through the notes once you get through here. A few things from geometry you might remember, maybe, I don't know. Some special right triangles, they were called. Close enough. 45, 45, 90. And the other one, 30, 60, 90. Close enough, all right. The special right triangle, 45, 45, 90, the sides were 1, 1, radical 2. For the 30, 60, 90, it was 1, 2, radical 3. If you know those, that's great. Make things a little bit easier for today's notes. If not, not a big deal. For the unit circle, the radius is always 1. So we're going to try to compare this to the hypotenuse being 1 now. Still 45, 45, 90. But the hypotenuse is 1 instead of radical 2. Different ways to do it. How could you find these missing side lengths? You could call them, I don't call them x if you want right now. And then just do Pythagorean theorem. You could say x squared plus x squared equals 1 squared. All right, still a right triangle, you can do that. This is 2x squared equals 1. X squared equals 1/2. And then square root of that, so x equals 1 over the square root of 2. And how do you get rid of the radical on the bottom? You multiply the top and bottom by that radical. So x is just radical 2 over 2. So in a 45, 45, 90, if the hypotenuse is 1, the legs are radical 2 over 2. All right, each one. We're going to use that in a little bit. If you have the 30, 60, 90, same idea, except the hypotenuse was 2. I want the hypotenuse to be a 1 now, so make another one. Close enough if that's 60, doesn't look like it, close enough. Another way to do it, instead of Pythagorean theorem, takes a little bit of work. If it was 2, I know the hypotenuse is now 1 because we're on the unit circle. Draw a picture of that in a minute. That's just half of it, right? So, like, think proportions. If this is 2, now it's 1. This was 1, now it's 1/2. All right, the picture's not the scale. If this was radical 3, cut it in half, it's radical 3 over 2. So, we're going to use these ones today for our unit circle. All right. Pretty much all this in the notes refers back to that. All right, on this page, the reference triangle are essentially triangles that we form within the unit circle. All right, this is an example of a unit circle. Again, everything, the radius is 1 on all of these. You're trying to find the coordinates of each point here. We're going to focus on like this coordinate right here, 30 degrees first. Some geometry stuff. If this is 30 degrees, this arc is 30, this central angle in here is 30. All right. So if this is 30, I know if I drop this perpendicular down, this is 90. This has got to be 60 degrees right here then. So there's lots going on here, but try to think about this little triangle inside here, right? 30, 60, 90 triangle. All right, basically we just did that. We know the radius is 1 because this is the unit circle. So that means from here to here, that length is 1. If you want to write in there, you can. It gets messy. We just did this though. All right, if that's 1, what was across from the 30? All right, should be 1/2. What's across from the 60 was radical 3 over 2. But we're not really trying to label all these triangles. That gets messy. We're trying to label these coordinates right here. So think about it. If you plot that point, though, it's over this far, up this far. So the coordinates are radical 3 over 2, 1/2. Right, that's the coordinates for this point. Let's do a couple more. This is 45, all right? So now, again, it gets messy. Now we're talking about like this entire central angle here is 45. That would make this angle 45. Here's my other perpendicular. If you want to bring it off to the side, you can. All right, so 45, 45, 90. Think about what we just did. Hypotenuse is 1. Each side is going to be radical 2. All right, radical 2 over 2. From here to here, from here to here. This coordinate is radical 2 over 2. Radical 2 over 2. Once you've done a couple of them, you've actually done everything that you see on here. Right, so it's the same thing over and over. This angle is 60. So the central angle is 60 down in here. All right, so actually this angle is 60. They're all different now. This angle here is 30. This is 90 still. So across from the 30 was the 1/2. So this is actually 1/2. This is radical 3 over 2. Your hypotenuse is still 1. All right, so the coordinates are just flipped from this one. It's 1/2 radical 3 over 2. A little bit different. Once you get used to it, not as bad as it may seem. Some other things that you should know as you go around here, right? At 0 degrees, this point on the unit circle, don't overthink it. What are those coordinates? That's got to be the point 1, 0. At 90 degrees, that's the point 0, 1. All right, keep going all the way around. 180, you know that one is negative 1, 0. 270 is 0, negative 1. All right, you can actually find the coordinates of all these points. Let's do one more just to make sure you understand this one maybe. Let's look at 150. All right. Yes, this angle here from all the way around is 150. What's the reference angle though? From the other day, if I drop down a perpendicular, that's 90. The reference angle is this angle right here. All right, what's left? How many degrees to the x-axis? Got to be 30. If that's 30, this is 60. Same triangles over here. All right, so it's going to have the same coordinates. All right, this distance is going to be the same as this distance. The only difference is you're going in the negative direction in your x-coordinate. So instead of positive 3 radical 3 over 2, it's negative radical 3 over 2. You're still going up 1/2. So anything on the unit circle,